Hello.
Hello, good morning, Tema.
Good afternoon for you, or almost good
Thank you.
evening. How's
Do
the
you know
weather in Madrid?
why? Oh, 34, 35 degrees. I bet in
Celsius.
San Francisco is not so high.
Yeah, actually, I'm going to do exactly translation to this means 95 for the our American friends.
Good.
95
Fahrenheit.
Fahrenheit.
Yeah, for
So
me,
that's
it's
a lot.
difficult to calculate immediately Celsius
So,
to Fahrenheit. So I don't know if you know why I have chosen this song, Under Pressure from Queen. It's because last webinar we were talking with the Stanford University girls about piezoelectric devices, it's about pressure. And today we are going to talk about dimensions. So I'm very I'm very happy to hear what do you have for us today.
yeah, today we're going to talk about how to play with the dimensions in designing magnetic transformer, specifically for a phase shift full bridge. And when I was reading the email of the invitation, I realized that you were mentioning about the size of a watch box.
Yeah.
So, what type of watch box? I mean, watch box are you referring? Are you referring to just the box where the watch is, or to the box, the
Do you know
enclosure,
the
the envelope
yeah,
of the box?
yeah, I mean the box when you put the what, not the this part. But let me show you. I have a face full read
No,
here, and this
transformer.
can be part of a
You just
what?
have the transformer, not the full replace it.
No, no, no. I only have the magnetic,
Yeah, yeah.
but not bad. If you are able to reduce the dimensions of the full converter, maybe can fit on a recipient of the box robot.
I mean, I think that a lot of people were thinking like, wow, that's really high power density. So I think that this now with the clarification, now that let's say that box maybe is not so crazy power density. Actually, it's going to be kind of medium low power density. So maybe we will try to do something in the middle today. Okay.
Okay.
Okay. So let me share my screen, and I will start setting the slides I have for today. Yeah. Let's go. So, as always, we have our brief introduction. So we are going to review some products, then jump into the webinar, and then you will see some kind of pricing again for this our AI assistant. Um, Products. So in our platform, as you know, our main focus is to solve the design of power converters and magnetics. So there are like two sides of the coin. One part is a Frenetic AI assistant that basically is going to help you to calculate the parameters of your converter and complete tasks like generate the LT-SPICE files, create a simulation for Frenetic simulator. So there are a few actions that this agent is able to do, and every month or yeah every month we are adding a couple of new two functions. So you will see these new functions today for our Frenetic AI system. And Frenetic Simulator is the place to go deeper in the design of the magnetic when you need to go to check exactly the leads wire, exactly the what let's say what is the comparison between one another. So that's let's say the step two. So today the idea is to talk about 500 bad design. So I got some specifications from working on these. So we're going to talk about an automotive case using the specs from similar specs to a Texas Instrument reference design for the automotive industry, or 400 volts to 12 volt, 500 watts. And the main constraint that we are getting initially is that we have a maximum height of 20 millimeters. So that's, let's say, our first limitation. As you can see, it's less than 20 millimeters, less than 20 millimeters. So we have, let's say, to make a design that is, let's say, lower in terms of height. So 20 millimeters would be right on the limit, but I would prefer something smaller. So now I'm going to share the brochure. So in the brochure here, you can see that I took, this is a 400, but in terms of parameters are very similar. So this is a 400 watt battery system for automotive. Actually, here we can see the schematic and everything for this phase shift full bridge. And actually, they're using a planar's magnetics. So I'm opening our agent and creating a new project. In the new project, I'm going to choose phase shift full bridge, and I'm going to start typing the specs. So this is 400 volts. This is 12 volts output. This is going to be 500 watt. And I'm going to write the specifications I want for, let's say, for just to have a very similar design to these ones. So the specifications, if you go here in detail, is like this is a 200 kilohertz. Sorry, 200 kilohertz in frequency. Tune ratio equal to 21. Well, I'm going to copy. I have here the text. I'm going to just copy and paste here. And I'm monetizing inductance of 2.76 milliamps. So let's start the design for this converter. Okay, so what we have here is that for these specifications and with these limitations, the system have created the, let's say, the converter, limiting to, let's say, fixing to 200 kilohertz. Then it calculated the output ripple for even actually have calculated an output inductance of 1.8. If you want to change that, you just need to type here the value you want to have. The duty cycle, the phase shift, tune ratio, and the monetization inductance. Now you can download the LT-SPICE for this circuit, and soon also you will be able to download the Plex. But the LT-SPICE is something you can just download. It's going to take a few seconds. I'm not really, let's say, going to open the LT-SPICE. It's just to make sure that I can download. But today I'm not going to run any simulation there because I'm going to focus on the constraints in terms of dimensions. Okay, well, but I have it here. If I need later, I can open. So I'm going to request a magnetic. So this is going to create a magnetic design for us for these specifications. There we go. So we have the transformer here. Is transformer, as you can see, is it's pretty fast. It can take like 30 seconds more or less in between each design. So it's a PQ3520. That means that we are right on the limit on the height, 20 millimeters. And total loss is 3.29 watts. So here we can see the specifications for the leakage inductance 3.73 and a little bit more magnetizing than we expected. So what we are going to do now is going to the simulator. So we are going to open the simulator. And this is one of the most interesting functions of the Frenetic AI is that it's able to create a complete project in Frenetic Simulator. So the project is totally created, the simulations have been run, and everything is here created. So it's saving you a lot of time, but especially is allowing you to do much more faster iterations. So let's say that we want to have a smaller option of 20 millimeters. So the first thing I would try to do is say, okay, can I just take out 1 millimeter here and see what's happened? So customize the core 1 millimeter smaller. So of course, it's going to change the inductance because it's changing, let's say, everything. So let's see what's happened. Um, so we're having some warnings because basically we are changing some data we're changing some data in the inductance. But looks like everything is fine. And so what I'm going to do is I'm going to compare both designs. So first I'm going to come back to the 20, run this design again, and come back to the operating points here. I'm going to add another design. So this design, I'm going to call it PQ3519. And this is the PQ3520. So in this second one, I'm going to come here and change this 19 and run everything. And now I can compare both cases here in both designs. So if I reduce the size for 1 millimeter, what I can see is that the smaller one is having like 3 degrees more. We have an increment in the winding and also in the core losses, but let's say it's kind of similar. So right now we already have kind of a design that is under these dimensions. But if I come back to my specs, and I have imagine that we have another case where we are adding another limitations like 30 millimeters by 20 millimeters. There is something else we can do here that is much more interesting. So I'm going to come here to this option and it's like limiting the design by dimensions. And I'm going to say, okay, limit solutions by 20 and 30 millimeters. I'm going to ask for, let's say, generate designs here, 3 designs. And let's see what's happened. Okay, now it's saying, okay, for that limitations, this is, let's say, you need to have, let's say, that is too much. So, okay, so let's put, 30 and let's say 30 here. Suggest design. So this will take some time. So we will come back here once the simulation is done. So what we are going to do in parallel is that, as you can see here, we have a new option here to see what can we do to have a smaller design. So let's click here. This is the design of a planner. So basically, in the design of the tax instrument, they have these planar design. So I want to have something similar here. So let's see what's happening. Okay, we have a first calculations bar. So we have a core material, number of turns per layer, parallels, also some distance between traces. And we have also here some parameters. Okay, so we have now the complete design of the planner. So now we can compare. So in terms of dimensions, this is of E30H. So basically, this is saying that the height is going to be twice 8 is going to be 16. So in terms of height, the planner design is going to be better. So let's want to check the planner case, planner dimensions. So this E38 has a height of 8. So in total, let's say 8 1/2. So both will be around 16, 16.5. In the F dimension is 25, so it would be working for the footprint limitation of 20 by 30, but the other dimension is too high, is A, that is 38. So in terms of height, this planner design will work, but in terms of the footprint, probably we need to keep playing with this concentric or chain the core here. But what I want to show you today, that is one of the last things we have been working, is that we are running behind the scenes FEM, particularly we are using console here to calculate the specific parasitic capacitance for this combination and also the resonant frequency. So here we can see that for this particular design, maybe we will have some troubles with these values of magnetizing and capacitance because the resonant frequency is too low. And then we would be able to iterate and say like, okay, for example, we can reduce the magnetizing to have a lower value and keep playing with the resonant frequency of a planner. So something to take in consideration when you are designing in a planner. All the information needed is going to be here. So so also you can try to analyze and compare the concentric case and the planner case. Let's see how the other simulation is going. Okay, still going. So I run it before because I know this one takes 2 or 3 minutes. So let me show you the results. So basically what it's happened is that I put the limitations to 20 to 30 and 30. Yeah, 30 and 30. And I got these 3 options. And the interesting thing here to know is that the system is very conservative in terms of flowing, let's say, of the energy. So so even if he's putting 62 degrees with forced error, if you take this design and you use it, let's say as an example, for example, this PQ 18, and then you run the design with free convection, the final temperature increased to 100 degrees, but it still is more or less under control. 100 degrees for a magnetic is still okay. But the most interesting thing is that dimensions are pretty, the density is very high. It's 27 by 20 by 23 for a PQ for 500 watts. So it's what we were expecting to have in our dimensions here, limited dimensions, 20 by 30 by 20. Of course, that this is something I have done in a few minutes. So if you want to keep having something more compact, like at these reference designs of Texas, you will need to keep doing some simulations and playing with the dimensions. But the good thing is that you can compare all your designs very easily here with the function of comparing designs and comparing also the, let's say, playing with the dimensions limitations here. Now, if there is any question, I will answer for sure. But before concluding this part of the demonstration of this technical design, I want to suggest something that I think is going to be very interesting for all of you that are working with manufacturers of, let's say, working for a manufacturer of magnetics or semiconductors. Sometimes you're doing a design and you want to share your design with somebody that is not using our technology, our platform, Frenetic Simulation or Frenetic AI. So what can you do? So now we have a new functionality that allows you to share a design with everybody. So let's say that you have built this flyback. This is actually for a reference design in Renesas. So it's a flyback transformer for up to 18 bats, and this is the core, the winding, and everything. So now we have created this link. So everybody with this link, and we can put this in the email after the meeting, can simulate this transformer for free and verify what they have. So if you have a customer and you want to send them a simulation of your design, you can just share this and say like, hey, you can play with this design under your own conditions and see how it performs in terms of losses in the core, in the windings, or even you can see how, let's say, is the magnetic field. So you can allow the user to play with your design. And that's all for today. I hope that you like this new feature of the planners that you can now compare classical design with planar designs, and also the capacitance model that we have included with very, very, very high accuracy. Um, let's come back
We
to,
have we have a question regarding the Planar new
let's
feature.
go.
If you go to the chat,
Yeah,
it's from
let
sending.
me see, chat. Is it chat or um, the chat, sorry.
Yeah,
Can the L and C parasitics of the planar design be exported as part of a transformer model into LTS packs? So you have the values, and you can take the values and just update it yourself in the LTS spice. What we are working is actually that these values are going to be updated in the model in the LTS spice. But right now this is not complete. It's in our roadmap. It's going to happen soon. But right now you need to do it manually. But you have the value, so it's not a big deal. So Gregory is saying like, great to have the planner. So yeah. Can we get the Herbert file of PCB trays for planar design? So you have all these details, and we have another tool that is, let's say, once if you want to go deeper in the planar design, we have a tool where we have the whole, what we call the YAML file, that is a text file with all the details of each layer and everything. So something that is almost directly the PCB Herbert file. So so we can help you with that. So for sure. But it's not, let's say, automatic yet. It's you have to download that file.
I think from now on, if some of you want to play with Frenetic AI and try the Planar feature for free, you can go to this link I have set in the chat for everybody. Yeah, you can try it for free with 24 hours of Frenetic Magnetic Simulator. Is that
And
an
also,
add-on? We have
I
another
don't understand.
question.
I don't understand the question. So before closing, you are going to share some pricing for this, let's say, for this kind of limited offer for this new launch.
Yeah, let me share the screen one very fast, because I would like to share this special pricing I have. As I have said,
It's not.
you can try for free.
Now it's in, yeah, now it's in the screen.
Okay, yeah. You can try for free, including Frenetic simulator for 24 hours. So you can try both tools and explore the whole path. And for these days, maybe if some of you have tried these days Frenetic AI, you have seen the banner. For August 3rd, we have 20 limited spots for this new offer, including the Planar Design feature. So if you are interested, we can explore together. But what is more important is if some of you need to explore magnetic simulator, we have this promotion only for these days, and 20 limited spots. And of course, as I have said, in the free license, you have the 24 hours for free, and the pro, if you want to upgrade to pro license, for this time, you have, instead of 7 days of trial of magnetic simulator, 14 days. So I think
somebody is asking
this
if
is good.
somebody is asking for the if in the hobby can test everything. So in the hobby you have limited access in terms of actions. So then you can simulate a planner, but you don't have enough credit to go to edit the curves or anything. So if you are interested in going more detail, so you need to move to the pro. And if you want to go to the more detailed, also you need to go for the Pro Plus simulator. So, well, I think that's all for today. So we invite all of you to go to try our new features for free. So you can just register, and you have, I think it's 8 or 10 credits on our side. So thank you very much for coming today, and see you next week.
Thank you, everybody. Bye-bye.